In this segment, we're going to be talking about Cartesian coordinate systems. And in the context of that, we're going to be talking specifically about some two-dimensional equations that will be graphed into those coordinate systems. Now, if you've taken some advanced math, you know that there are actually three dimensions that we can visualize, and we call those the x, the y, and the z dimension. On the SAT, you're only going to be dealing with an x, y coordinate system. And what we're going to be talking specifically about are the equations of a straight line and the equation of the parabola. Those are the two different types of equations that will be graphed on a Cartesian coordinate system on the SAT. So with that, let's take a look at an actual Cartesian coordinate system and see what some of the characteristics are. All right, let's take a look now at the parabola and its relationship in terms of the Cartesian coordinate system. Of course, a parabola is going to have a U shape, and the bottom of that U, the very lowest part of it, is called the vertex. And we're going to examine now exactly how you know where that vertex is. When you, on the SAT, you'll see an equation, and it's going to be very important for you to know when you see that equation exactly where the vertex lies. And I'm going to show you some shortcuts, and then I'm going to show you the general mathematical theory behind that. Let's look at the general equation of a quadratic, of a parabola, and it's going to be ax squared plus bx plus c. Now, you've seen this before. You say, gee, I've seen this second degree polynomial. Here we have three terms. It's a trinomial. And I factored that before when I was doing quadratic equations. It was the product of two binomials. Let's say maybe it was x plus 5 and x plus 5. That may have been what the equation was. And if we had gone ahead and multiplied that out using FOIL, it would have been x squared plus 10x plus 25. And we even learned to go, if you've reviewed the segments here, we've even learned how to go from this equation over to the product of two binomials. And it's really nice when it's squeaky clean like that and you end up with two binomials. But sometimes there's what I call a Whittle constant outside. Let's say it was the same thing, except maybe it had a minus 2 out here. So when you factored it, you end up with this little Whittle over here. So our equation became this, minus 2. So instead of being this, it was this, x squared plus 10x plus 23. Now, both of these are trinomials. Both of them will result, if you plot them, in a parabola. But the parabolas will end up being different places in regards to this Cartesian coordinate system. So the question is, if you see an equation, a parabola equation on the SAT, how will you know where the parabola is going to be on the Cartesian coordinate systems? That's usually the way the SAT questions are framed. So let's examine how you do that. Let's first write that simple. We said it was x plus 5 and times x plus 5. That's the same as x plus 5 squared, and our y would equal that. And that's one type of trinomial. Another type was the second type we showed, where it was y equals x plus 5 quantity squared minus the 2. The important thing here is if you see an equation like that on the SAT, the constant that's inside the parentheses and the constant that's outside the parentheses both mean something in regards to the location of your vertex of your parabola. The rule is this: the constant that is outside the parentheses determines where it is in relation to the y-axis up and down. The constant that is inside the parentheses determines where the vertex is in regards to the horizontal axis, left or right. Now, the rule is, the one on the outside, you can just look at the sign and you know that it's negative, so it's going to be down this way on the x-axis, somewhere down here below the horizontal line. But the rule for the inside here, you see it's got a plus sign, and you probably think, well, that means, okay, if it's going to be in the axis, it's going to be over here. It's just the opposite. It means it's going to be on the minus side. So we know that in this case, by looking at this 5, it's going to be 5 units over on the horizontal axis and down 2 units. So our parabola would be somewhere down here in this third quadrant. Another thing to recognize is that if there's a minus sign in front of one of these equations, let's say the equation is y equals x plus 5 squared, we'll use the same one there, minus 2. If there's a minus sign out here in front of that, instead of the parabola being shaped like this, it's going to be downward instead of, it'll open up downward instead of opening up upward, if there's a negative sign in front of it. Now, in terms of the general equation, what I'm saying here is if this is a minus sign, if there's a minus sign right here, the U shape is going to be inverted. It's going to be opening up downward. Now, I've shown you the shortcuts for when you look at an equation, knowing where it's going to be placed. There is an actual formula for knowing exactly what the coordinates of the vertex is. And again, the vertex is this part right here. And that is the two components. The x component is minus b over 2a. And this a and b, of course, refers to our coefficients. And the y component is 4ac minus b squared over 4a. And so if we had an equation like this, we would just go ahead and plug in the numbers. So for instance, let's take this equation right here, x squared plus 10x plus 23. Our a would be equal to 1. Our b would be equal to 10. And our c would be equal to 23. Now, I won't take up a lot of time plugging all that in, but if you want to verify what the x and y components are, all you have to do is plug those values for a, b, and c into this information here. That's your x component, and that is your y component. So with this general information, we're going to now take a look at some actual problems that you may encounter on the SAT and see how you can use this general information to find a correct answer.